Good morning. It's the second day of the Casting Specialties drill press vise build, and as you recall, yesterday I milled these two slots, so I'm making quite a bit of progress. And the size, remember, was 3/16, and using a couple of gauge blocks I was really right on. Remember, I had my doubts as to whether the 9/16 end mill would produce a 9/16 slot, and it really did. Perhaps a thousandth play in there, but there has to be a little play with this. So what I'm going to do first on the jaw, I'm starting the jaw today, is just to true up the two sides here, and I'll mill that. But before I do, I'm going over to Palmer's belt sander and knock off the fire scale on both sides here, and then I will mill those two sides so they are truly parallel. Be sure and wear your safety glasses at all time and practice every safety rule you can possibly think of. I always give a warning at the beginning of my videos regarding safety. Now, I just rethought this a little bit, and these two sides here are not parallel, so I'm going to set this on a parallel down there and tighten it up and just true this surface up, and that way it's going to grip properly in the vise when I do the other two faces that I just talked about. And this is that nice 3/4 inch carbide end mill by Niagara. Touch off, raise it about 10 thousandths. I may be telling you way too much, but now that this has been machined, this surface is more or less parallel to this, even though it hasn't been machined. And when I place it on these 1 3/4 parallels here, it is not going to tilt or lift on me. It remains on the parallels. So now I can tighten it down and mill off this surface. I don't believe I've mentioned this, but if you're not able to grind the fire scale off, it's best to take a cut, initial cut, that is deep enough that it's cutting through the fire scale and down to good metal. And that's less likely to dull your end mills. So I'm taking off 5 or 10 thousandths. And also remember, you can never be too rich or own too many parallels. Now I'll take a skim light cut across this surface to true it up. And it'll take one more light cut. It didn't quite clean up here. I'll do that off camera. Alrighty, both sides have been milled. Now the next thing I want to do is to mill here and narrow this lug here such that it will fit into this 9/16 slot with just a little bit of play. It can't be too tight, perhaps 2 thousandths, I'm just guessing. So I've already laid it out. I found the center, which isn't necessarily the true center. I wanted it pretty much centered with this crown here, whatever you might call that. So I transferred the line down, brought it across, drew a 9/16 diameter circle and a couple lines. So those are my layout lines. And what I'll do at the same time that I'm milling the width here is to mill this surface, and I'm not sure of what the dimension should be on that, so I'm just going to clean it up to start with. Oop, wrong way, Corrigan. Like that. And you can see it's a little bit higher, so I have considerable amount to take off, perhaps 1/8 of an inch or so. Here's the setup for the jaw. Now normally I like to center the work in a vise so there's no stress on the jaws, but the reason I'm off to the side here is that I set it up using a parallel across here, a stop if you will, so that later on when I mill down to the dimension, if I'm off and I need to take a few thousandths more off or whatever, I can get it back in the vise probably pretty much the same to take off a few more thousandths. So that's why I'm off center. I like to approach that dimension very slowly and deliberately, and now I'm still not on my layout lines, but just for the heck of it I'm going to measure it right now. And I'm at what is it, 708. This will be the last pass on this side because I'm just about to the line. Alright, I'm on the line, and I switched to a caliper. Seems to work a little better than the micrometer to get in here. And I'm 582. About 582. I'll go over to the other side now. I'm at 575, so I've got 12 or so thousandths to go. Take it in one more pass. And I'm looking at the digital readout and moving it in 12 thousandths. Right. $564. I wonder if that'll fit. I doubt it. I'll take one more light pass and then take it out of there and check it out. See if it fits into the vise body. Okay, here's the moment of truth. Will it fit? And it does. Is it sloppy? It has to have a little bit of wiggle, or it's going to bind and be problematic. And notice that the height here is about right. Bringing it down here, you can see that this will all be machined as one after the screw is made. There isn't a whole lot of extra material here, but it's looking good. Now I can't tell you in teaching school how hard this was for students to make this fit. In fact, what I ended up doing is I had extra patterns made so that when the students made their base casting, they made 2 jaws. So they had a second try at it. Not only that, but for the very few students that did get it on the first try, that allowed me to eventually get a pool, a drawer full of extra jaws. So, and I did that on other projects too. They were problematic like that. So now I have to machine this down. It's too long. So I have to determine how much to take off of that and then make a steel bottom plate and have a couple holes drilled in there, and I'm going to use these button head 1032 screws to hold that on. And what I'm talking about there is this plate on the bottom. This is too long, too high. I have to remove something off of that, but how much? And here's how I determine that. There was a little inclusion right there, which won't really hurt anything. I put the jaw into place, just got a setting in there the way it's supposed to be, and then using my depth micrometer, I measured the depth right to that surface, to this surface. Then I measured the depth again to the ledge right here and found the difference. So the two dimensions there were 406 and 354. I subtracted. There's 52 thousandths to remove, but I really want a couple thousandths in there, so I'll make it 50 thousandths. And I'm going to go over to the mill, set this up again just the way I had it before, and touch off and then raise the knee 50 thousandths and mill that off. I'm not going to show that. Using this 1 inch wide, 1/8 inch thick cold roll steel, I cut off a piece of the appropriate length and width, and I may trim the sides of that later on, but that'll be my keeper that'll go on here. And I took the liberty of finding the center line there and laying out 2 holes and center punching them. So off camera I will drill and tap them for the 832 screws. Then I will in turn use transfer punches to transfer them onto this. Now you may think that's backwards, so if you would rather in a job like this drill the holes in this piece and then transfer them onto these, well, a 6 of one, half dozen of the other. I always drill these holes extra deep. I don't know if you overheard me or heard me over the sound of the drill press, but that was a number 21 drill, and I drill them extra deep. Well, why? Because I don't like dealing with a shallow blind hole. This way the thread will probably be longer than what I need, and that's fine. So I'm using a 1032 taper tap, and then I'll go in there with the 1032 bottoming, not bottoming, plug tap. So I don't have to use a bottoming tap, which will be a great source of grief in your life. Nice thing about cast iron, it leaves very little burr, if any at all. Now look at how deep I drilled these holes. Now they're probably not tapped quite that deep, but that way I don't, there's less chance of breaking off a tap. Notice that I didn't use any lubricant. This taps just beautifully, but again, you got to be careful. You can still break off a tap, and then that divides the world into two kinds of men. Those that swear and those that cry. I've talked endlessly over the years about the virtues of transfer screws. I've already got one installed, and this is 1032 Hyman. Little wrench on the end, little socket wrench. But there's always somebody that never heard of these, so I'm speaking to those people, and I want to screw it in there so it's just a little bit below or above the surface so I can feel both of those. Can you see them? Then I'll put the jaw into place. Notice the little X mark there, by the way. And I've already prepared this piece. Little X mark on one end. Get it just where I want it. And, well, I thought I had a brass punch out here, but I didn't. So I'm just going to use a regular punch and whack it. And there's two center punch marks, one there and one there, and I'll go in there a little bit deeper with the automatic center punch on that one. Looks kind of anemic. And I'll drill those clearance for 1032, which is what? 3/16. There it is. Now you have to make sure that you have room on each side for just a little shim stock. And it might have been better if I would have put some cardstock or paper on each side before I transferred the holes. Because you want it to be able to slide full length, and there's going to be just a little wiggle. You want some, or it'll be problematic. Now the hardest part of all, and the trickiest, is going to be drilling and tapping this in alignment with the hole that goes into here. As you know, there's going to be a hole in there, and then a little set screw on the top, just like the palm grin. But I'd like to stop at this point from the castings and make the screw and the handle, and then I will go back, drill and tap this hole with the set screw in, make the handle, and then it all has to be milled down so it's smooth and even as this one is. I'm at the Clausing 12-inch lathe, and this operation is devoted to producing the screw for the cast iron casting specialties vise. This is 3/4 inch stock, and I have to turn it down to 500 thousandths because I'm going to turn or thread it 1/2 13, so I've already faced it and center drilled it. That black mark is the length of thread, which is about 5 1/4. I've set a stop, and just for variety, to do something different, I'm using a half center, a carbide tipped half center. That's not a live center, that I got from BANGGOOD. A half center gives you a little more room in here to work. So I do like that feature. We'll see how this works out. It's kind of an experiment, and I'm using, of course, CMD Extreme Pressure Lube number 3 as a lubricant. It has to be lubricated if it is not a ball bearing center. A lot of you have grown up with live centers that are bearing type and aren't even familiar with this procedure, I suppose. Now, the carbide tip, I would hope, also wouldn't melt off like the high-speed steel does, although I'm going to watch the lubricant in there. So I'm ready to turn it down. Don't care much about the finished because it's going to be threaded. Alright, I'm turned down to diameter, which is 500 thousandths. I'm right on, although it could be just a thousandth or 200. Now, the next thing I want to do, since I'm going to be threading here, I want to create an undercut here that will be 400 diameter with this cutoff tool, and about 2 or 2.5 widths of the cutoff tool, and that gives me a place to terminate the thread. And now I'm ready to thread. That will be 13 threads per inch, and this is not going to be a full-blown threading demonstration. You've seen that in many of my other videos, as well as other people that are on YouTube. So just show some fast clips here of threading it, and I want to take it down to where a nut, hex nut will fit, but the pitch diameter is 0.450, and I do have a thread micrometer which I will use, and it doesn't have to be exact. I just need it pretty darn close is what I needed, so let's go. Alright, I'm just about there. The hex nut goes on. It feels just a little tight, but checking it with the thread pitch micrometer, it's about 454. So I'll take another cleanup cut, see if that brings her right on down, and then I'm done. One more cut probably. I really need to blow it off. Goes on a little better. And let's see what the mic reads. Oh yeah. I'm right on. 450. Now the last thing I'll do before I take it out of here is to take a file and just gently file the top to get rid of the very sharp crest of the thread. But that thread's done. Now I still have to cut this off because it's on a 2-foot long piece, and I need to turn the end down and remove the center hole, but I'm going to do that later, probably hold it in a collet for that purpose, but I'm ready to take it out of the closing lathe. And here's how to drill a 1 size over 1/4 inch cross hole. Perfect every time.